It's kind of late, I'm tired, but I'm going to go ahead and do the review. I'm going to do this a little bit differently. I'm not going to go over the notes. I'm not going to give test questions or anything like that. What I'm going to do is draw a concept map and try to see if you guys can connect the dots. This might be a good idea for you actually to get out a sheet of paper and something to write with as I go through this. Now I'm going to kind of do this in two parts. Part one, I'm going to be looking at the history of the atom. And then part two, we're going to see what's going on with electrons and whatnot. And then part three, we'll probably have to talk about isotopes, isotopic notation, things like that. So I may very well be making 3 videos out of this, but we'll see. Okay, this is the first time I'm doing it this way. Well, when we start looking at the idea, we've got to look at the idea of the atom. Okay, that's our central idea about the atom, and I'm probably going to need my glasses in order to make this happen. And that would give people an opportunity to see what's happening. So for the atom, okay, we can look at the history, we can talk about the Greeks, and they came up with the word atomos. So there's one part of the atom dealing with the Greeks and the word atomos. But we also end up getting the law of definite composition. So, what's up with the law of definite composition? Look, for water, it's going to be always made up of 2 hydrogens to 1 oxygen. Sodium chloride. 1 sodium, 1 chlorine together. Boom, that's it. Okay, that's definite composition. Composition, what is something made up of? Definite, it's, yep, that's it. It's a fact, Jack. Moving on. So with that, of course, with the atom, we have to talk about the nucleus. Now, you guys already know, the nucleus is the center of the atom, and of course, we are going to have parts of the nucleus. So the first thing is, we got to look at protons. Because protons work, let's face it. Protons, positive charge, okay? As you guys know, that is a positive charge. That's why I wrote the positive sign there, okay? And of course, the idea is Rutherford discovered. Okay, so Rutherford discovered this in that experiment where they shot radioactive particles through gold foil, okay, and that's when they had a, oh, you gotta be kidding me moment. Are you serious? So that's the dealing with that. But we also had neutrons. And I'm going to go and I'm going to do this in a different color. So we had neutrons. Now, you guys already know neutrons. 0 charge. You guys know that. You also know that, hey, it was Chadwick who came up with the idea. So you know that Chadwick was the one who came up with the idea. So the nucleus had protons and neutrons. Okay, protons positive, neutrons no charge whatsoever. Now, of course, the last one here, as we look at it, our last part, you guys might remember something called electrons. Okay, well, what's up with the electrons? Well, the first thing we know is it's a negative charge. Okay, they're very tiny, they don't weigh much, negative charge, and that was good old J.J. Thomson who found out. He used a device called a cathode ray tube, okay, and that's what he got to work with for that. So this is pretty much it with this whole idea about the kind of the history, but now we have to look at something else. What about the personality? What's going on here with those electrons? We got our players, we got our neutrons and protons and electrons. What else do we have? And this is where I'm going to have to take my green one and draw that down here. Okay? Because we got to talk about Heisenberg. You might know good old Heisenberg. There is no idea of location and no idea of energy of the electron. Now I am putting this up on YouTube so you guys can go and view it over and over again. But for us, now I'm just working with this as we go along. So that's what Heisenberg said. We don't know the location, we don't know the energy of the electron. We just don't know. And that led to the idea of the cloud formation, the cloud theory, ultimately. Okay? And that's where we had the cloud theory. Okay? So that's pretty much when you are looking at the history of it. Okay? So if I look back on the whole thing, all right, you guys can see it. Atom, Greeks and atoms, law of definite composition, nucleus of the atom, you got protons, electrons, neutrons. Heisenberg said we don't know where they are, we don't know what energy they have, and that's what led to the cloud theory. Okay? So that is it in a nutshell in terms of the history for the atom. But now we got to start looking at some of the specifics of the atom. And that, I'm going to switch to the next page, and I'm going to kick the view thing up to 100%. Now, if you didn't get all of it, that's not the end of the world, because I am putting this up on YouTube so you can catch that. Okay? And again, we're looking at the big picture of what's happening. So with that, guys, we have to sit there and we got to start looking at electrons. Okay? We have to start looking at electrons, and then of course I'm making sure I got the right position of this. So, okay, what do we know about them? Okay? Well, we know that there is an address system. There's an address for the electrons, right? That's a key thing. So the first one has to do with the principal energy level. That's the big one. Principal energy level. Wait, because remember the address has 4 parts. Okay? So part 1 is principal energy level. And that goes with 1, 2, 3, all the way to 7. Okay? That's your principal energy level. Then we go with the next part, and that is our sub-level or orbital. And remember, that's the shape. That is the shape of the area that the electrons are hanging out in, and that is S, P, D, F, G, and H. Say, well, do we need to know all those letters for the test? No, S, P, D, F, and you are fine. Know how many there are in each, okay? That's not going to be on the outline, but hey, I did mention it on the review. And if you don't see the review at home, and you're taking the test, it's on you. Yeah, because I'm giving you valuable information here. I'm not wasting anybody's time, believe me. Okay, now there is another part of the address for the electron, and that is orientation in space. Okay. Well, what in the world are you talking about? How are these sublevels, orbitals, oriented in space? You could look upon that as example x-axis, y-axis, z-axis. Now, there is more to the story, but for just gives you guys an idea. Now, there's one last piece of the address for the electrons. One last piece, and that has to do with the spin. Okay? The electrons have to have a spin. Now, why do we care about that? Because there was that dude. Okay, I gotta make sure I can see. I gotta go up here. See, will it show it? No, not really. Okay, that's fine. We're gonna do it another way. Okay, so the spin, it's going to be one going up, one going down. That's the thing. They have to spin opposite of each other, and that would have been the Pauli dude. Pauli! Yeah! Pauli! He's the guy who came up with that idea. His face is in the notes. He looks like he's about to pick a fight with somebody. Okay? So this is dealing with electrons and their address. Okay? Now, let's go ahead and let's move on to another part. Okay? Okay, some ideas. Aufbau Principle. Now, Aufbau Principle, it means construction. Okay? Electrons go to lowest energy that is open. Okay? That's the Aufbau Principle. Electrons go to the lowest energy that is open, that is available, the lowest energy level, guys. That's when we talk about the electron address. How are the electrons lining up? Okay? Now, that means when we look at something like this, that means there's a certain order that the electrons fill in. So they'll go in order 1s, 2s, 2p, 3s, 3p, okay? And that takes care of a lot of things, but then it goes to 4s. Then after that it's, oops, not 4d, 3d. And we're going to stop there, okay? You'd say, wait a minute, why is the 4s coming, filling up before 3d? Well, here's the thing. Here's the basic idea behind it. Okay? So you got 1s, and then up on the next level, you got 2s, then you got 2p. All right? Now remember, this is the energy level, right? This is our energy level. Okay? Then you have 3s, 3p, and then you normally would have 3d here, right? But right in there you got 4s. Notice how 4s is in between 3d and 3p. That fills up first. Okay? Think about the sunny room and the pink room. Think about it that way. Okay? So that's a pretty easy thing. Now we can also look at it and say, all right, what about those funny little arrows? So we can look at 1s here, say one arrow going up, one arrow going down. Okay? Then 2s, one arrow going up, one arrow going down. Okay? That's the idea. Wait, where are we at? Electron addresses. This is electron orbital notation, and this is electron configuration. This is orbital notation. It tells the same story, except with the arrows, it tells you specifically where the electrons are heading out. Okay? Moving on here. We also have something called Hund's rule. Okay? At that point, I'm going to look at monopoly. Okay? When you're looking at Hund's rule, I call it the monopoly rule. Fairly simple. When you look at 1s, 2s, and here's 2p, the way it works, guys, you have to go 1, 2, 3, then go back and fill the 4. That's the monopoly rule. And let me fill in these here. This stuff is already in your notes. It's already in your notes. It shouldn't be a big deal. Okay? So, in looking at this, let's go back here. So in looking at it, we're looking at electron address. This is the same idea. We talk about the Aufbau Principle. Electrons go to the lowest energy that's available. It's open. In that, we got things like 1s, 2s, 2p, and so forth. And it has to do with the energy level that the electron has. And then we talked about electron configuration here. This is electron orbital notation. We talked about Hund's rule here. Okay? As far as how the electrons are going to fill this sublevel. Okay? Just like a monopoly. I can't put 2 and 2 and leave this blank. It's got to be 1, 1, 1, then go back and fill. Just like in monopoly, ladies and gentlemen. Okay? Alright. This stuff, quizzed you on. So hopefully you got that. Alright? But I'm going to stop this, and then what I'm going to do, I'm going to talk to you guys about isotopic notation, give you guys a few minutes to write a few little details. Okay? Yeah, I had dinners at Brandon's tonight. Had it with this gorgeous blonde woman. Oh, yeah. I mean, she calls me up out of the blue and say, "Hey, do you want to have dinner with me?" And I'm sitting there going, "I'm right there, girl." Oh, wait, yeah. Oh, I guess you weren't supposed to know that. I don't care. I don't care. It's my wife. It's just my wife. Had an awesome dinner, though. Carnitas! Yeah. All right. I'm stopping here because we're going to have to work on part 3. This is part 2.